Hi everyone, this video is to show you how substitution and rearranging equations can be used outside the classroom. Now generally, substitution and rearranging equations go hand in hand, as we often have a need to rearrange an equation to get it into a certain form, and then substitute values into it to get a solution. Now believe it or not, you rearrange equations more than you think you do. It doesn't always have to involve letters when we're doing it, and when we do it, we tend to do it quite quickly and without much thought. So I'll give you an example. So let's say you and your friend go to the shop to buy a drink. Your friend didn't realise it was cash only and only has his card. So your friend asks you if you can pay and then they'll give you the money back later. And the drinks in total cost £3 and you know that your drink was £1.20. Now it should come to no surprise that your friend's drink would have been £1.80, and you probably worked this out without really thinking about it and sort of got the answer straight away. But you've actually formed an equation without thinking about it and then rearranged it to find how much your friend's drink was. But you would have done this really quickly and you wouldn't have realised what you've actually done. So let me explain. So we know the amount you paid was £3, so we have some stuff is equal to 3. Then you know how much your drink was, but you didn't initially know how much your friend's drink was. So initially you would have thought, well, the price for my drink is £1.20. Plus the cost of my friend's drink is equal to £3. So we can write this mathematically. So we have £1.20 or 1.2 plus x is equal to 3. Then you filled in the gaps and said, well, £1.20 plus £1.80 is equal to 3, so the drink must have been £1.80. So we can write this as x is equal to 3 minus 1.2, which is equal to 1.8, so we have £1.80. So pretty simple, and you wouldn't really do this mathematically, you would just do it in your head. But this example is no different to examples that you're asked to complete in class, apart from this one has some context to it, and sometimes the one in class are a little bit more difficult because it might be in form of a fraction or there might be an extra term. But the idea of quickly working something out in your head and not realising what maths techniques you're actually using happens all the time in mathematics, as often it's difficult to make a link between completing exam-style questions and actually using maths in real life, whereas we do use maths in real life all the time. As you wouldn't really think of the problem we just mentioned in terms of algebra, you would just think 3 minus £1.20 is £1.80. So now I actually want to give you an example where I've used substitution and rearranging equations before in order to work something out that I couldn't exactly do in my head and that you perhaps couldn't really do in any other way other than using algebra. And before I was into maths, I used to manage some restaurants where I had hourly paid team members, and as part of their role they was entitled to something called holiday pay. So this is where you earn or accrue time where you can take a holiday and still get paid for it. So most people are entitled to at least 5.6 weeks holiday for a full-time job, but this varies depending on things like the type of job you have and the amount of hours you work, etc. Anyway, I was once asked the following question about holiday pay, which was, how many hours do I need to work in order to gain one full day's holiday pay? So basically they used to get paid every 2 weeks, and on their pay slip it told them their holiday day balance, which was in days. So it might say something like 1.21 days, for example. And I didn't actually know the answer to this, as it varied on a lot of factors, such as their hourly rate and the amount of hours they do for each week, because it might vary. But you could easily work this out as an estimate from your pay slips by looking at how much your holiday pay balance goes up from your last pay slip to your current pay slip. But in order to calculate an exact amount, I would have to make an equation where we can input some information and then it gives us back the information we need. So what I knew about holiday pay at the time is I knew that everything was calculated in pounds and then converted to days after. And I knew that 12% of anything they earned is the value that goes towards a holiday pay, which means if someone earned £100, then the company would pay £12 to go towards the value of a 1 day for that team member. And I also knew that one holiday day is equal to 8 hours worth of pay. So one holiday day in pounds for somebody would be 8 hours times by the amount they get paid per hour. So I started to make some type of equation based off of that, which gave me something along the lines of 12% of the number of hours times by the rate of pay. So I had the number of hours times by the rate of pay, and I wanted 12% of that, and that would equal the holiday balance in pounds. So what that basically means is if they've worked 50 hours in 1 week and their rate of pay, which is how much they get paid an hour, is £10, then that's obviously £500, and we need 12% of £500, and that's how much goes towards a holiday balance. And now if we write this in a more formal way, we could say that the number of hours worked times by the rate of pay divided by 100 and times by 12 is equal to the holiday balance in pounds. All I've done there is we've taken how much money I'd get from that week doing 50 hours, and then in order to find 12% of that, we've divided by 100 and times by 12. Now, the holiday balance part isn't actually that much use to us in that form, because we want to know how many hours we need to work in order to get one holiday day. So the holiday balance needs to be in the form of one holiday day. And since we know that 8 hours is equivalent to one holiday day, then we could say that the holiday balance in pounds is equal to 8 times the rate of pay. And also, let's stick a variable in there just because it will allow us to find 2 days and 3 days instead of just the 1. So we'll put a d next to the 8, where if we wanted to know the amount of hours for 1 day, we would make d equal to 1. Or if we wanted to know the amount of hours for 2 days holiday, then d would equal 2. So now we have the number of hours worked multiplied by the rate of pay divided by 100 times by 12 is equal to 8d times by the rate of pay. So at this point I've made my equation. If I were to input the number of hours worked and my rate of pay, and then also make d is equal to 1 because I want to know 1 day, then I could indeed find out how much holiday pay I was going to have based off those hours and that rate of pay. But we actually want to know the number of hours needed in order to obtain one holiday day. So to do this, we want to rearrange for the number of hours worked. So we have the number of hours worked times by the rate of pay divided by 100 times 12 is equal to 8d times the rate of pay. And then if we were to rearrange for the number of hours worked, then we'll start off by getting rid of the times 12, so we need to divide both sides by 12. So if I divide the left-hand side by 12, I would have the number of hours worked times by the rate of pay divided by 100 is equal to, and then we would have 8d times by the rate of pay divided by 12. And then next what we want to do is get rid of the fraction on the left hand side, so we need to move the 100 to the right hand side. So we need to get rid of the divide by 100 on the left hand side. So in order to do that, we need to times both sides by 100. So on the left hand side we have number of hours times by the rate of pay is equal to, and then we would have 100 times by 8d times by the rate of pay divided by 12. And then lastly we need to remove the rate of pay from the left hand side, so if we divide both sides by the rate of pay, that would leave us with the number of hours. So we have the number of hours is equal to 100 times by 8d times by the rate of pay divided by 12 times the rate of pay. So now we have an equation that's in terms of the number of hours worked. So now let's say somebody wanted to know how many hours they needed to work in order to get one holiday day, and let's say their rate of pay is £10 an hour, then I can substitute D as 1. So we have 100 times 8 times 1 times by their rate of pay, which is £10 an hour, so times by 10, and then that's divided by 12 times by 10. So on the numerator we'd get 100 times by 80, and then on the denominator we'd have 120, and then on the numerator we have 100 times 80, which is 1000, divided by 120, and then if we put that in the calculator, 8000 divided by 120 is equal to 66.6 recurring, so I'm just going to leave that as 66.67 hours, which means over the 2-week period, because they get paid every 2 weeks, they need to work 66.7 hours in order to get one holiday day. So if someone worked 33 hours a week, then they would get one holiday day each payday. So then now if anyone was to ask me the question of how many hours they needed to work, I was able to whip out this equation and then substitute the values for their rate of pay, and then I'd be able to tell them how many hours they needed to work in order to get a holiday day. So this was actually quite useful for a lot of people, because some people like to collect their holiday days and then use them for a big holiday, or some people like to just take the odd day off throughout the week and then get paid for it. So it was definitely worth doing the calculation. Now, this is definitely not one of those things I could have done in my head, and I had to actually use the knowledge I had about holiday days to form an equation and then rearrange it for the thing I wanted to find out. But it's a good example of where substitution and rearranging equations might be used outside the classroom. And I don't expect anybody to fully understand the maths behind everything we've just done there, but I do hope you have an understanding that rearranging equations can crop up anywhere in all sorts of scenarios and can actually be quite useful. But I hope you've enjoyed the example, but for now that's the end of the substitution and rearranging relevance video.